Howdy everybody out there on YouTube. Well, I know it's been altogether too long since I put out some video material, but here's a project I thought I'd share with you guys as a way of getting back into it. It's another Mosaic integral chef knife. We're gonna do some neat stuff on it, and I'll walk you kind of through the process. I gave you guys a video on cutting with the Pantograph, but I didn't really give you a video on pattern generation, so I'm going to attempt to remedy that here, and let's take a closer look. Here's our blade. It's about 8 3/4 inch blade length chef. I've done some drawings mostly on the computer, and I would like to do this little pattern here. This is part of a greater tessellated pattern. We've just isolated basically one pattern element from it, and it should pretty well complement some of these shapes that we have going in the Damascus. I made sure to break up the front of this and the back of this as not straight lines anymore, and have them sort of play well with the lines in the front and back of the pattern here. And then I have made a double-sized drawing on paper here so I can cut it out, and when I've done that, I've made sure to make all of the little chamfers on the corners here, the fillets on the corners, be the size of the stylus that I'm going to use. In this case, 1/8 inch, and then the final cut on the handle will be 1/16 inch corner fillets. So that'll kind of make more sense as we get into it. But right now I'm going to cut this out and spray glue it onto some 1/8 inch polycarbonate pattern stock. We got it bandsawed out rough, the outline of the handle here, and we're just going to finish grind it up to the mark with 120 grit, but we need to make sure that the table is square to the platen exactly, because this needs to be usable from both sides. You flip it to do the other side of the handle. So if there's any taper or even slight angle to the sides of the finished pattern pieces, you won't get a good pattern cut from the other side when you flip it. Having got the edges of this smoothly ground, now I'm going to start these inside shapes by drilling out the corners so we have a nice arc, and I'm going to do that using an 1/8 inch bit, which is going to be our stylus size. So because of that, I'm pre-center punching where the drilled holes will go, and I'm using an 1/8 inch transfer punch so I can get right up to where those holes need to be. And then I won't really have to mess with finish shaping the inside radius of these holes when I'm finishing up making the pattern negative here. We'll just use what comes off the drill bit. And I'm using polycarbonate for the pattern here. It's a plastic, so, and it's thin, it's 1/8 inch, so it's easy to generate patterns in it. It machines cuts pretty easily. But specifically for center punching it here and things of that nature, it's better than acrylic sheet. I think I've found acrylic sheet to be a bit more brittle. So this polycarbonate sheet being a little bit more tough will put up with more abuse, put up with drilling better, punching better, and then you won't have like cracks in your pattern through the thin parts. That could be a real pain. we got the negative all cut out, roughed out on the little scroll saw. Now we're going to take it over to the die filer and just finish the insides of these smooth up to the line, and that'll be the pattern negative. Over here at the die filer, I've got these arms adjusted down to where they're just barely hovering on top of the work here, not really pressing on it, but it also can't ride up at all before hitting these feet. Now we just got to undo this and lift. Well, that's actually not the case. In this case, I actually have to undo the bottom two so I can thread the file down through the work, because the hold downs are in the way. But that is not a problem. And the holder here is already snugged up, or already the table is squared to the file, which it has to be, much as the belt grinder table had to be squared to the platen, because again, the inside walls of this need to be perpendicular. So we've tightened the file. Now we're just going to put a little tension on the top nut, and we should be good to go there. Yeah. All right, let's fire it up. I always start it real slow. I don't actually run it terribly fast anyway. It's not bolted down or anything, so I don't need it walking itself across the floor. Here we're just using a flat file. And we're just going to file our way up to the edge of those drilled holes. So we intersect it without a sharp corner anywhere. And even where we've sawed pretty close to the line, we're going to go over it lightly with this, because it just smooths up the insides of the pattern and makes it ride smoother on the stylus, which is nice. So what we can do with the flat file here is limited to flat or convex surfaces. We'll switch to a different file when we're doing convex parts of the shape. So I'll probably just come along, do all the parts of the pattern that need a flat file, and then do all the parts of the pattern that need a convex file, and so forth. And just filing right up to the line. There we go. So that's that part. Now, let's play Where's the Allen Wrench. And we'll go to the next one here and do the same thing. I'm going to switch sides of the file and use an ungunked up part. Now, every other time I take the file out, though, I am going to need to brush the plastic swarf out of it. So I'll see you guys when I am done with this part. Okay, so that's pretty much all the work that we can do on the die filer. I don't have a smaller chainsaw type file modified to fit it right now, or rather I just don't have the file. It's easy to modify them, but there we are, filed out. And now we'll just drill some pinholes, 1, 2, 3, 4 probably in this, and find a backing plate for it. Here is where paths diverge. This is one way to do it. There are other ways to do it. One would be casting the positives into the negatives, and perhaps I may show that sometime. I've been doing a lot of this. It's less messy, a little faster, I think. Well, it is. You could do it all the same day because you don't have to wait for epoxy resin or whatever you use to cure. So I've taken this, I put it on top of more pattern material. I marked this with some color to it first to make the lines show up better. Otherwise it's very difficult to see when you're cutting to it. And I used a very sharp, thin carbide scribe here to carefully scribe all the way around the insides of the pattern. Now I'm going to go take these, cut them out, and finish grind and file them right up to the lines and then start hand fitting them. We're over here at the die filer. I have pretty much removed all the excess material on the borders of these down to barely short of the line with 120 grit on the belt sander. And now we're just finish fitting here using the die filer to very controllably, slowly remove little bits of material, and then we're just check fitting as we go. So I got this one, number 2, fitted up pretty well here. I want them to fit with just a little bit of friction, but I also want to be able to hold it up to a light source behind it and see that there aren't any light gaps. So while I'm fitting it, I look for areas where there's more light interference and where I think it needs material actually removed, and I remove material there. And then I just gradually fit it down in until I stop getting interference anywhere. So this one is good. You can see it just stays in there, but also very easy to push through. Now the middle of this pattern is pretty flexible because the web here is thin. So what I'm going to do as I get close to fitting this one in, I'm going to leave this in so that I'm not getting an inaccurate fit by flexing this over here, if that makes sense. So I'm just going to go ahead and do the other crescent shaped one here and just, again, very controllably, slowly remove little bits of material until it fits in there just so. And now we've done all the die file work. Probably took about half an hour to fit this tightly into, fit the positives tightly into the negative there. And only the last one will fall out, but it does not rattle in there, so that's going to be a good fit. The other thing is, this is a double-sized pattern. Don't know if I've talked about that yet, but since the Pantograph is a reducing pantograph, it won't do one-to-one, at least directly. I make the pattern twice the size exactly of the original handle. The nice thing is that when you trace a double-sized pattern to cut a workpiece half its size, any little errors that you have in the fit-up of your pattern pieces which you should strive for there not to be, will also get halved. So you ought to get a very nice fit because of that as well. So now we'll actually go ahead and drill the holes and mount to a base plate and then go from there. Well, I found the material that we're going to make our base plate out of. This is some 160 thou pink G10 that I got 10 years ago for a custom order. Made one little EDC handle for the customer, and then it's sat here not getting used for anything really. So I think it's time to part it out, not for knives, but just for fixturing and stuff. I like composites a lot for pattern work because they are dimensionally stable. They are hard and durable. And particularly G10, unlike micarta, doesn't really shrink after you drill it. So it'll hold tolerances on things like pinholes for indexing better and with less fuss. So this ought to really make a nice base plate for us. I'm going to scribe the outside of the pattern and then cut and sand this out to the line. There we go. And then we'll be able to use this itself as a pattern if we want to trace the outside of the handle profile onto a block with the pantograph if we wanted to. Okay, so there are all of, there's the entire border for the negative set. So now we are drilling pinholes through the pattern into the backing here. And we're going to pin them as we go. These are 3/32 stainless pins, and we need everything to index perfectly after we pinned it, so that's why we pin them as we go. And we want a tight fit. I'm using a 3/32 bit. It's sharp, and I'm using 3/32 pin stock, which is just a little bit too tight for these holes out of the package. So I've sanded them lightly just by hand with 600 grit until they fit easily enough to push and pull by hand, but snugly so that a piece can't wobble at all with even 1 or 2 pins in it. So that's good there. Now we're going to drill 2 pins into each one of these through as well. And while we're drilling the small pattern pieces, we'll also pin them as we go. And so forth. You just get these knocked out. Okay, so now our pattern pieces are pinned down to the base plate, all removable, re-indexable, and now we'll just cut the outside of the profile here of the pattern, and we'll be done with it and ready to throw it on the pantograph and use it. Quick note about this little guy. This is a little drilling table. It's a riser block drilling table with a clamping ledge underneath. So this is actually a lot easier to clamp and fix your little parts onto. For drilling, you can use smaller clamps. It's much more positionable on the table, and then you can hold it, or you can just very easily like manually clamp little stuff onto it for drilling. And it's got a replaceable micarta top, so when this gets chewed up too much, you can flip it over, or you can just put a new one on with these 2 countersunk screws. I've gotten a ton of use out of this over the years. I really kind of like it, so maybe you'd like one too if you made one. So here is the result. I've done a video about the actual use of these on the pantograph, cutting with them, so we won't go super into that. I'll show a little bit of it, and I'll show the finished result real quick. But for this video, now we've gotten to the fun part. After generating the pattern, the fun part is getting to use it on the pantograph and see how it works. But here is our finished pattern set. It's all pinned together. Take these pins out, and then we can pull the negative, and then you can see the positives pinned to the plate here. No wiggle in these, and the pinholes go right through the plate, because after we've cut this side of the handle using this side of the pattern, then we'll flip the pattern and the pattern positives and negatives, everything, and pin it to the other side of the base plate, mirrored of how it is now. And since the pinholes all go straight through, then we'll be able to reuse the same pinholes on the same pattern pieces from the other side, so it's entirely flippable, which is nice. You can take these off one by one. For instance, if the stylus you're going to use to trace this pattern is, say, 1/8 inch, and the gap between any 2 of these pattern pieces in a tight area is a little smaller than 1/8 inch, which I don't think this is, but hypothetically, then you could actually take, pattern pieces off, anything that's causing interference with the stylus, and then just like cut these 2 and then these 2, or whatever you needed to do. So that's kind of nice. I have run into interference, when one of these is a monolithic pattern, for instance, if they were glued down to the base plate, you could have some issues there. But with everything pinnable, removable, then you can kind of customize the layout as you're cutting if you need to. So we'll set this back on there. I got to make the rest of the knife, machine out the handle block first and stuff, and get it far enough to where I can clamp it up on the pantograph and begin doing this part. Okay, so I've done the setup work here. I want to cut these positives out of this workpiece at an angle and in a spot on the workpiece where it preserves the rest of the material, where I can get both sides of the positives out of this one piece for a nice matching color. So I've angled them both a little bit to kind of place this shape where it makes sense within the confines of this piece to preserve the material. And then I've taken and run my cutter here around the edges of what I'll be cutting on the pattern, and just made sure it doesn't stray outside the boundaries of this piece, that the piece is turned so that it's sitting where I want and in the rotation that I want, respective to the pattern. So, and then I put a grid basically all over the back of this, a small super glue tacks, so that whenever I break a piece free as I'm milling it, it doesn't break the surrounding material free, but also each piece will have probably a couple of super glue tacks under it holding it down until I'm done milling it, which is also important. So the depth of this scale is 200 thou. I fly cut it down to 200 thou because that's how deep I'm going to have my inlays before subsequent work. And I've set the dial on the knee height to where I found the workpiece at 0 on the dial, and then by the time I get to 190 thou, I'm going to very carefully cut that remaining 5 to 10 thou of material so the piece just breaks free. You don't want you want to have precise control over your depth when you're cutting, especially when you're about to break free. And then I'm using a 1/16 cutter and an eighth inch stylus here, so that I can cut the small contours of the pieces here, but also take the least amount of waste possible with this little cutter. But I will be needing to take pretty small passes, 10 to 20 thou a pass, while vacuuming it as I go to clear swarf, just to be careful and preserve that little cutter. All right, the pattern negative is removed from the set. Now I have the base plate with the pattern positives pinned to it. I've got an 1/8 inch stylus and a 1/16 inch cutter, and I'm running at 2:1 reduction here. And I have the stylus run down to where it's just hovering over the base plate by about 10 thou, so I get a true reading off of the kind of maximum profile of these pieces. If there's any low spots near the edges due to inaccuracy in making it, I'm not going to be reading off of those. I'm going to be reading off the maximum profile of these. So I am going to go ahead and get the spindle going here. It's at a high RPM, and get the vacuum going here to clear my chips as I go. I'm probably going to have to remove one of these as I cut because the stylus won't quite pass between those two like we talked about before. So I'm going to make a bunch of passes to get down through this, and when I'm barely breaking through, I'll do it in a few thou increments and just gently tap each piece off the super glue as it comes off the pattern. That's the plan anyway. Here we go. So obviously I sped this up a ton. I also cut out a bunch of instances where reaching down and moving the table up, cranking the knee up by 25 thou had bumped the camera, so you wouldn't see that, but I have done that. Every time you see the image jerk there, that's me feeding it up. So we flipped the pattern to the obverse side, or the reverse side, and we flipped all the pattern pieces over too and repinned them on. I didn't turn this, but since the element is at a diagonal across the piece, I can just cut the other one pretty well with it positioned as is. I just used the Y and the X cranks there to reposition it to the extent needed, that if I hand trace this around the edges of the pattern here, we can see that at no point does it exceed the boundaries of the wood, although I get it very close, and at no point does it impinge upon the previously cut pieces. Those previously cut pieces have about a 5 thou web left before milling into the base plate, so I've left them tacked on there. I'm just going to mill all these other pieces for the second side and number them as well, and then we'll tap them all free of the super glue tacks and then we'll have a full pattern set of positives. Then we'll cut the negative spaces into the actual block of Chicate. There's side 2 up on the top left, cut and numbered. You can see that we're pretty much down to the base plate in a lot of areas, so those ought to chip off of there just fine with some light taps with a hammer and a soft punch and some care. Let's see how we fare with this little bit of craft stick as a punch. Good. I want to use a punch that's even a little softer than the workpiece if I can. Okay, that's good. And I want to break this stuff free with the smallest amount of force possible, because as you can see, sometimes it'll go flying. Nice thing was I didn't have any of these pieces I want to break loose early. Sometimes if that happens, you can accidentally chew them up a little bit with the end mill because they're very close to the other pieces and to the waste parts of the block, since you're using such a small cutter. Okay, there's all of the side 2 pieces broken free. And you need to be careful not to tap on any pieces, like the thin parts of any of these pieces, because you could end up just breaking the inlay piece accidentally by hitting it on a weak spot. Or if the burl is like too intense and has too many little weaknesses within it, that adds to the amount of risk. Gosh, if I'd quit dropping this, that'd be great. All right. Great. Also, if they go flying and fall, you could also break one when it hits the floor. Luckily, that didn't happen there. So we've got all of our inlay bits broken free, and that is excellent. Now we're just going to go ahead and probably take a file and lightly deburr all the little flakes from the bottom there, and then we'll be ready to machine the female sides of the inlay. A quick note too about some pattern location and transfer ideas. I got this out of an old book probably, but I'm sure it's a very common thing. So I wanted to have a true representation of where the pattern was on this side of the handle. So when I'm placing it down, locating it to the pattern on the pantograph, I can actually have it cut on exactly where I want within the boundaries of the handle. So I had this is a hard pattern though, and this was good for doing the profile and mating it up to the steel there of the bolster, but not good for this. So I took just another one of these pattern pieces from the cutout from the sheet of actual size pattern printouts, put it up against a window and carefully traced the back side of the drawing to put lead on there. Then I put it back on this side, held it carefully within the profile, and drew hard over it on this side to press the lead from this side of the paper down onto the surface of the wood, which gave me a pretty good transfer, and then I just went over it with pencil. So now I have a very definite representation of exactly where I want to put that pattern on this handle. And pretty soon I'll be grinding the knife bright. You can see some pattern poking out of the heat treat scale there. But with that, and with the handle kind of all machined and fit up with the tang nut and stuff, we can actually throw this on the pantograph and cut the negative sides of the inlay. So I don't have any fancy platen tables for this thing. I just use the strap clamps, and most of the time they're completely adequate. Or I'll just use a G10 pallet and then super glue stuff down to it if it's just little stuff. So what I've done, I've put the pattern negative here, and I have used a square to space these 2 points exactly off the table, the leading edge of the table, the same distance. And then I did the same for this piece. It's not necessarily the same distance as this piece, but these 2 points are the same distance off the table edge. So I've basically squared this edge of the block to the table and that too, and that saved me a lot of setup time of like clocking both of these, how they're supposed to go. And then with the pieces at least linear, then I can dial this table around in Y and in X just to kind of get it located to where this pattern will read onto it. And then when I think I've got it where I want it, I'll leave these clamps a little bit loose so I could tap this block around if necessary. And I'll just ride around in the pockets of the pattern here with the stylus, and I'll check to make sure that the spindle is exactly where I want it on the block with my drawing. Ride it around on all the pockets, and then adjust a little bit with X and Y until I'm splitting the line everywhere with my cutter run right down, hovering over the surface of the work. And then when I'm done with that, I will clamp both of the tables in X and Y so nothing moves if I bump a lever wrong. And I'll make sure the strap clamps on everything are dogged down good so nothing can shift. You don't want anything shifting while you're cutting because that'll just scrap your piece. And with that, we'll be ready to cut. A quick note on cutter and stylus choice. So with a 16th inch end mill to do the negatives, it takes forever of mowing the lawn inside those inlay pockets to do all the passes necessary to remove the material with that tiny cutter. So we're going to remove most of the material with a 3/16 4-flute carbide end mill, and because of that we're going to use a 3/8, double the size stylus. However, this is a double-ended stylus. I got this with the machine. One end is 375 thou exactly, the other end is 380 thou. So we're going to use the bigger end over here to trace the pattern with, and that'll keep us to a roughing mode. It'll keep us away from the finished dimension of the walls by, well, 2.5 thou per side. And then after I'm done with the 3/16 end mill, I'll switch it up and I'll use this double-ended 1/8 collet that's just been turned on the lathe. This is exactly an 1/8, and this is 130 thou on this end. We'll use the 1/16 end mill, rough it out, all the little corners with the 130 thou. Then we'll try fit the inlays. And if they're still demonstrably too tight, then we'll go with the spot-on size, the 125 thou stylus. And that's why I usually cut the negative second, because you can just have that sitting there, cut a pocket, try an inlay in it, and if it's still too tight, then you can go back and with this still indexed, switch to a slightly smaller stylus and route the outside wall out just a tiny little bit more for a better fit. You can't really do that the other way around if you cut the negatives first. So that's the method behind that madness. As I have been milling this with the 3/16 cutter, I'm making sure to only have the pattern piece out that I'm actively tracing and keep the other ones in so this pattern doesn't flex around on me. And now I've got them all rough milled out with the oversized stylus. You can see the corners aren't really finished because that 3/16 cutter and stylus pair won't get in there. So now I'm going to swap it out for the 1/8 inch roughing stylus and 16th end mill. And there we have it. One side is done. I mean, it's going to need a bunch of shaping and, refitting with glue and all that stuff. But the inlay routing is done, the pantograph work. those are fitting in there. Not a press fit, but they don't have any wiggle either, so that's good. And I actually used the oversized stylus and then check fit these before switching to the exact size stylus, and it's a good thing I did because they actually fit in there well with the cut given by the oversized stylus. So remember that. Always start with your last cutter and stylus set with a slightly oversized stylus, and then check fit before moving to the spot on size, because sometimes they'll fit a little earlier than you had predicted. Anyway, that's one side done on the Pantograph. Here's a final step. Brought the camera in close so you could see these location / push through holes. I put a 3/32 end mill in there and plunge cut those part way down through there. The plunge cutter wouldn't, the end mill wouldn't reach all the way through because of the flute length, but I will just finish drill those with a 3/32 bit on the drill press, using those plunge cut holes for guides, just to finish them through to the other side of the block. And coming over the arm there, you can see that I used the actual pinhole locations for the pattern pieces with a tapered stylus here, pointed stylus, and I just push those down until it's snug and the stylus can't move, and then plunge cut my hole. And once I've got holes under each, 2 holes under each one of these cavities, then I have holes that if I get an inlay piece stuck in there, I can actually push it back through from the other side with a piece of 3/32 pin stock. So there's that. The other thing is when I flip the block over here on the Pantograph, the other side's going to be blank, but I want it to be aligned with the inlays on this side. So then I can use the holes after I finish drilling them through on the drill press. And then when I get the block flipped, I'll run this cutter down into one of the holes, and then I'll come over here and use that to align my pattern here. Kind of the reverse of what I've done in locating and then drilling the holes. So that way my inlays are in the same spot on both sides of the block. Work continues. I've got this side of the handle museum fit to the bolster, and all of the inlays have been relieved on the back and are now museum fit to the handle and mirroring the contours of the handle. I really like the way that looks beyond just a standard flush fit glued inlay, kind of quilted, or inset at least. Now to do the other side, which is just like that still. Well, here's a finished clip of the knife that the inlay handle went onto. They usually look better in indirect outdoor light. You can see this Damascus has got 3 tones: the background, the kind of mid-grays there, and then the overlay of brighter 15 and 20 patterning all the way up into the bolster there. A compound grind chef. The handle turned out nicely. You can see the inlays pop well as a color contrast. This side is a little bit lighter, the other side's a little bit more orange. And then I finish it up with a 2-tone tang nut there, bronze and stainless. We have slight heirlooming all the way around the bolster joint there. So, yep, that's how it wrapped up. I'm glad I decided to actually relieve the back of the inlays on this one, and expect to see more of this stuff going forward.